Hi everybody, I'm Zaid. That's my next slide right here. I'm Zaid. I've never really met anyone here except Mike, I guess. So hi to everyone here. Hey Dimitri. Dimitri used to work at Benzinga before I joined Benzinga, so I get to see his code all the time. So I'm one of the few people here lucky enough to see his code. So my name is Zaid. I work at Benzinga. I have, I guess, a master's from Wayne State University, and I've been developing software for like 15 years now. And I also have a funny picture over there just to make everyone laugh, and I decided to do that. So basically, the main talk about this is, the main talk that I'm about to give is basically how we do state management in our UI in React, global state management in our code base. So a lot of you guys are familiar with Redux. We do use Redux in some cases. We don't use it everywhere. There are certain scenarios where we don't use it. And basically the conversation here is why we don't use it everywhere and what else we use. So the reason that's the case, and I'm hoping this video works, let's go, is this is the tool I work on. So is the video even working? It's just a picture right now. Oh, things are popping, things are moving. Cool. That is not coming in right. Whatever. It's not as grainy as this normally. I promise. It's something to do with compression. I think it's the scaling of the video. Never mind. Basically, what I work on is basically a buttload of market data, as like, for example, a news feed, stock market, stocks changing, price changing, charts on the graph, all that kind of stuff. And basically, data's constantly moving. We have multiple WebSockets on all the time. And we basically need to be able to refresh this page really fast and get things popping without like having too much time re-rendering and stuff like that. So things need to, like specific things need to render at specific times, and not everything needs to render, and we need to just make sure the events get to the right place, and that's basically it. And that's basically the main tool I work on a daily basis. So basically the talk here is explaining what we do to manage all this event stuff and how we get this moving. Basically what we use is a subscription-based model. So basically specific components in our UI get to select exactly what they want to listen to. And they can be very specific. For example, if you're looking for a specific quote price for Apple, that component right there that's simply displaying the price for Apple can subscribe specifically for that piece of information, and it will only get notified on it. It will get a callback basically when that piece of information changes, and then that way it goes and decides to re-render. That's basically the main architecture behind all of this, right? So that's basically what we do here. So the way we do this is basically this blah blah code, and I'm hoping everyone can read it. If you can't, I might be able to zoom in or something, but I'm assuming yes? Yeah. Cool. Basically, just start out over here, and we're gonna go that way. And I'm gonna just move this, just so everyone can see. Oh, dang the camera, sorry. Hopefully that helped. So basically over here, we just have a wrapper around a set. And this is as simple as that. We just have a set, keeping track of numbers, really simple. And we have this wrapper, and this is back to OO. I know Dimitri loves this. Basically going back to OO, I know a lot of people hate OO, but I honestly believe that every kind of architecture, like development style, has a purpose where it's good. OO has a really good relationship when you're trying to do state management and trying to make sure that state doesn't change, and you know exactly when it changes. You have a getter, you have a setter, that's where it changes. It's all contained in one little easy spot, and that's it. That's where OO actually shines. And like with functional, that's not the case. It's always like something is holding on to the state somewhere. But OO is also has the functions part of it and the state part of it, which is honestly a good thing sometimes. I'm not saying OO is great everywhere. There's just certain places where it's good. So over here we simply have a set, and we have two functions: add to the set, remove from the set, right? And apparently that breaks everything. So basically, if you add to the set, we simply check, do we have this number in the set? If we do, or if we don't, sorry, we add it to the set, and then we dispatch an event saying add, and we specify the number over there. Really simple, right? And then same thing with remove. We check if the number is already in the set, we delete it from there, we tell everyone to remove the number. It's a really basic concept, right? So that's basically this. Up top, these are the events that you will receive if you subscribe to this subscribable, right? So this class extends subscribable. If you simply call the subscribe function to the subscribable, you will start receiving these as a callback when you give it the subscription like callback. Really simple concept. Over on that end, so this is where it's harder for me to read, but hopefully, can you see the mouse? Sorry. This is how you use it. Straightforward. First of all, you make an instance of this. You can then subscribe to that instance. You will receive back a subscription, right? And then when you subscribe, you give it the callback that you want to give it. You will then basically be able to use that callback to determine which kind of event on that specific value you would like to listen to. And then you could do whatever you want with that, right? So in this case, we're just simply console logging. Over here, we subscribe again to it. So now we have two different subscriptions for the same piece of data. Each one is simply console logging something a little different. And down here is actually where it starts running, right? So over here, we console out started, and this is the output of the log. So as you can see, we print out started. We add an item to the set, which means up here, this guy prints out added, and then this guy prints out included. And then after that, we remove, which means this guy says removed, this guy says removed. Then the first guy unsubscribes, so this guy is no longer subscribing, right? And then we add and remove, and then down here you'll see just the second person outputs things. And then that's basically it. We unsubscribe, and then we end. And that's basically the full model that we use. Obviously, it's all crammed in into one space. Any questions on any of that? Go ahead. Microphone, sorry. For recording purposes. Oh, yeah.
Thanks for sharing, Zaid. Question, do you pay attention to, or does it matter the order that the subscriptions are called? So in the way we use the model, it shouldn't. From like in our reality, it shouldn't. But yes, the way it works is whoever subscribes first gets the first response. But the way we use it, that's not really why we care, because it's mostly for display purposes we use this. So like and stuff like that, and simply getting events on the screen, whatever it could be. So it doesn't really matter who gets that to display. But for the most part, yeah, that's basically it. It doesn't matter for our use case. I can see why it would for someone else. But yes. Any other questions? Okay. In summary, this is kind of how Redux works. If you want to think of it in terms of Redux, it's not that far off. You can think of this as a OO implementation of Redux. If you want to think of it that way, that also works. Fair enough. And okay, so basically, how do we use this at Benzinga? Well, so at Benzinga it's more complicated. So like obviously, we're not just doing sets. We're doing stuff that's more complicated than sets. We group things into these things called managers, and depending on what kind of data it is, like what kind of data you want to subscribe to, each one of these goes into a different manager. Like for example, the example I was talking about was quotes, right? Which is like, we have a quotes manager, right? And in that quotes manager, we have everything related to quotes. And in my example here, I'm talking about watch lists. Watch list is, if you've ever used Robinhood, or if you ever used Webull or anything like that, you could make a watch list of all the tickers that you're interested in. Really simple. So we have a manager responsible for your watch lists right here, right? And this is what's inside the manager. So what you'll notice is each manager, we use a monorepo at Benzinga. We use a gigantic monorepo, and each one of these managers is its own package with its own package.json and everything, right? And each one of these managers is completely responsible for the data that it's representing. So for example, when it comes to watch lists, this is responsible for getting it from the server to basically presenting it, notifying you when it updates. For the case of watch list, it's a RESTful API. So we have it set on a timer that it automatically goes and grabs from the server, like maybe once a minute or something. So that way, in case you're on multiple devices, your device will eventually get updated. It might not be instantaneous. For watch list, it doesn't matter that much because you're not on multiple devices literally at the same time. So But yeah, but it does eventually to get update. But so this is one of the main things we do over here. So every concept we have is basically its own manager. And the manager itself is a subscribable, but the managers themselves have functions in there that you could say, hey, I want a specific feed, is what we call them, for a specific content type. So for when it comes to the quotes manager, you can go and say, hey, I want a feed for this ticker. And that way, anytime that specific ticker gets updated, you get a you can subscribe to that feed specifically and only get notified on that subscription. And that's how we kind of do that system right there. Okay, so my next slide is, so this is a fun slide. So basically, how do we use this? The concept of a manager. The concept of a manager, and so just a heads up, this whole concept of managers is designed not just for the UI, we could technically use it in the Node.js, completely server side. There's nothing preventing you from using these managers per server side. We actually have a couple people doing it already. So the first thing you would need to do to use these managers is, this is where, this is my favorite 2 lines of code, actually 1 line of code right here, because line 34, when we designed this, it took us forever to figure out what the best way to do this was, and this is where OO shines, I'm gonna be honest. So the way this works is simple. So the first thing you do is you create a session. A session is responsible for your authentication and anything related to your authentication. So in this case, we have an authentication key for the watch list, right? So this basically allows, like, maybe we were giving this to a third-party person who wants to use our API. They can plop in their authentication key there. It would automatically know that that authentication key is for that particular service, right? And then my favorite line, which is line 34, which is session.getManager. And what you'll notice is oh, whoops, I didn't mean to do that. What you'll notice is we throw in watchlist manager, the class, right? We don't throw in an instance, we throw in the class. And the reason we do that, so what happens is we throw in the class actual name, and it will give us back, oh, whoops, that's a typo. It should say watchlist manager, not auth manager, sorry. This is what happens when you write code real quick, just for a demo. You'll notice it'll give you back a singleton that it's holding on to itself. So each session, you can have multiple sessions on at the same time, and then the sessions themselves create their own singletons and hold on to their singletons. So the way that works is actually really cool, is if you'll notice all the way down here on line 37, is the watchlist manager, sorry, I don't know where I'm pointing, watchlist manager has to implement a static, if no one knows what static means, this might be a good question to actually ask in the class. A static function called getName. Does anyone know what static? Okay, cool, 1 person, that's great. Thank you for being the volunteer. Okay, so static simply means that the function doesn't belong to the instance, it belongs to the class itself. So that way, what that simply means is, you're not calling that on the instance. So if you make an instance of a class called array, right? That array will have a function, let's say, called getLength, right? And that will simply return to you the length of that instance, right? But what if you wanted a function that simply has nothing to do with an instance? You wanted a function like array.from, if you've ever used that, where you can convert some other type into an array. So it's simply grouping it with the class itself. It has nothing to do with instances. It's another way of doing namespacing, if you want to think of it that way, if that term comes to ring. It's basically including it as part of the class itself without being part of the instances. Does that make any sense? I'm sorry that that's complicated. Good? Am I good? Great. So the way this works is because we have this static function called getName, and it says Benzinga /watchlist. This will know instantly that, hey, the type up there that you're giving it for the class session is basically the environment related to this particular manager. It will also know that when you say get manager, session has a built-in map that basically it will simply call this function, get that name, go look it up in its built-in map, and then it will give you back the singleton that it has, and it returns it back to you. And that's the way it works. That's basically it. So that's the whole mechanism on how these managers work and orientate with each other. Any questions? Sorry, if there is.
So normally when you're creating a session, you might have other keys in there as well.
Oh yeah, you could be using multiple managers, and this is a basic demo. In ours, we literally have a JSON file filled of them, and we have one for production, we have one for staging. So basically, when the app boots, we have it so Webpack figures out which one it is, and then it goes and grabs it and then creates the whole environment for every manager and you can specify what you want in there. Key was just a random thing, but like managers could have other URLs, for example, is another one that we use where we could have different URLs for staging. Yeah. Anything else? Cool. So how does this work with React? This works really easy with React. All we have is a custom hook. We put that in our hooks. We have a package in our mono repo called hooks that we just throw the use subscriber hook into. And all we do is we have our session, we say give me that manager, and then you can give it the callback. And the cool thing is the custom hook is responsible for subscribing, unsubscribing, all of that stuff for you. You don't have to worry about any of that stuff because it will figure out when you dismount and any of that stuff. So from a user standpoint, this is what they're actually looking at the end of the day. They're not making managers themselves, they're just using managers, right? So all they're looking at any given day is like this. And they're like, oh, okay, this component, I need to subscribe to a quote. So okay, I want to go to this manager. I can ask for a specific feed. In this case, I didn't have a feed, but like let's say you had a feed for a quote, you would plug in a quote feed there instead. And then you would give it the callback, and then you can set the value or you can do whatever you want. And that's basically how that system works. I don't know what the next slide is. Yeah, I don't think we need to talk about that. Any questions? Go ahead.
Do you use this software for high frequency trading?
So we have day traders who use our software all the time. So it's not high frequency the way you're thinking of probably, but for the most part, it's used by day traders who basically need to do that. So they're not like algorithmic high frequency trading.
Because my question actually is, what's the delay or the processing time in your software from the input to the output when you actually give the information for something to happen? What is that?
I actually don't have a number for you.
Okay.
I'm gonna be honest.
And does your code change if it's for whatever stock trading? It's a fast code, whereas for the other applications, the slow one because it doesn't have to be that fast.
So our main concern is simply getting the data to the screen. So I don't know what you mean about fast, because by the time it gets to the GUI, it's not going to matter as much. You know what I mean?
Okay. I mean, in a trading, whoever is first might have a competitive advantage over the others.
This is true.
So if it's 100 milliseconds or 50 milliseconds, so that's why I'm asking. Like,
but by the time it gets to the rendering part, I don't think it's going to take hundreds of milliseconds. But you know what I mean? By the time you get the data through our backend, through all that stuff, that's going to take longer than depends on. I don't actually have a number for you, so I'm sorry. But I can tell you this from a performance standpoint, because what we looked at was pure performance benchmarks on before and after, and trying to like see like everything render faster. That was much faster, to the point that it was noticeable once we started implementing a lot of this stuff into the system. Because like I was talking with Dimitri before, with Redux, what happens is, and I know he said that there's new ways of doing this, but the ways we were doing it before is we had that connect function, if you guys are familiar, where you place that all the way at the end of the file, connect, and you throw in a buttload of stuff in there. Well, so the issue with that method of doing it is anytime the Redux state updates, it needs to do a diff comparing what it had before versus now with the variables that you have there, right? So that means you're literally doing a diff on every single component, simply checking the current variables you care about in that connect function versus the previous time it got those variables, right? So to do that diff, it's gonna, that takes some processing to determine if it needs to go and render again, right? Because it needs to do that should render kind of system, right? You need to do that should render all the time, basically. Well, with this, there's no should render, right? Because you're specifically getting the event directly that you care about. So there's no should render anymore. And that was the big advantage there. So yes, so that's basically that. Okay. Any other questions? Go ahead.
Cool. So this would be like a component, for example, that would call this hook, and then you would have access to the data you want?
So yeah, so in here you'd get the event that you want with the data you want. So for example, you'd get event, like up here, updated watch list, for example, right? And you'd get an event, oh, whoops. You'd get an event, and this event tells you that the watch list updated, and with the event is the new watch list that was updated. So then you would do whatever you want with it. In this case, we're just setting the state, a basic demo. But like you might have something else that your component does more, like they might be looking for something really specific. In this case, like the watch list one, we simply, like if the watch list you care about gets updated, you get a notification. And the reason I specifically chose the watch list manager because it's the easiest one to understand from a demo standpoint. But like there are other managers that we have that are much, much more complicated, right? That basically, this one's a RESTful API, but some of them are like, let's say WebSocket. And like with the WebSocket ones that you're constantly getting information, right? And then also you might want to pinpoint it. So your manager would be would be more complex, and you would have functions in there to get you back certain subscribables, right? That so you can get subscriptions on really, really pinpoint things, and then you can do whatever you want. Sorry, yeah, that's cool. Okay, anyone else? I have other slides, but I don't know how much you guys wanna go through. Yeah.
So I'm guessing a lot of the complexity in this is sort of hidden away in your base subscribable method. Is there any magic going on in there, or is it using something like RxJS, or like how are you actually doing the subscriptions?
If you want, I can show it to you. It's the ugliest TypeScript you'll ever read. Am I sharing? So yeah, that's working. Let me find it real quick. Util subscribable. Oh yeah, so we are going to open source a lot of these managers. We actually got someone working on it. I was hoping to get it before this talk, but the issue is when you hire a contractor to do the documentation for you, nothing ever works out. How do let me see if I can zoom in, make this real. So yeah, so the way this works is very ugly and very TypeScript heavy, and this is a talk unto itself. But all of the subscribable stuff happens in this file right here. And the thing that makes it TypeScript heavy is because the events typing gets carried over. So when you subscribe to it, it automatically knows what the callback should be. Like it knows what's coming back on the callback. So it's very, very TypeScript heavy, and it has a buttload of magic in here that honestly I would have to like comment, like talk about for an hour to explain. This is what's called ugly code. The previous talk explained this very well. But yeah, so this works. Yeah, I do have to clean this up, but that's part of the magic. We are gonna clean this up. That's the thing. We're cleaning this up right now to open source it, and we're talking about it, how to do that, and that's the goal. This is I don't usually use the laptop, so this is a really old checkout too. But yeah, so yeah, this is a whole talk. Sorry. Thank you.